25. Assuming ideal solution behavior, how many liters of HCl gas, which is measured at 30.0 degrees Celsius and 745 torr, are required to prepare 1.25 liters of a 3.20 molarity solution of hydrochloric acid? Okie dokie. So, assuming ideal solution behavior. Now, ideal behavior, especially in terms of a gas, right? This is talking about your ideal gas law. And the formula for ideal gases is this one right here, right? We know and love this one. PV equals nRT. Now let's see how far we can get with this formula, right? Now under this ideal gas law, this ideal behavior, ideal gas behavior, they're asking for how many liters of this gas. So the V stands for volume. That's what we're trying to solve for. They did tell us that we're at 30 degrees Celsius, right? So 30 degrees Celsius would be the temperature, 30 degrees. However, when you're using PV equals nRT, Celsius, not allowed, right? So we just have to convert Celsius into Kelvin. And to go from Celsius to Kelvin, all you got to do is plus 273 or plus 273.15, depending on how specific you want to be. So this would be just 30 plus 273.15 would be, I think, 303.15. And that is your temperature in Kelvin. So that's a check. Now they told us that we have 745 torr, and torr is a unit of pressure. So we got this covered. Unfortunately though, just like with the temperature, 745 is not the right unit for PV equals nRT. 745 torr has to be converted into ATM. And in order to go from torr to ATM, you just divide by 760. So know that conversion. So I'm just going to take my 745 divided by 760. And I'll give it a couple of decimals. So 0.980. That should be good enough. So I have my pressure. I have my temperature. I'm searching for the volume. R is always a constant value, 0.0821, or if you want to be more specific, it's 8206. And the units for this R value, the gas constant, is ATM times liter divided by mole times Kelvin. That's why you have to use Kelvin for temperature. You have to use ATM for pressure. You have to use liters for volume, and the N value is in moles. So we have this checked out. The volume is what we're trying to solve for, so that means that I should have the N value. But if I just read it over again, they didn't tell me anything about how many moles I had. So how am I going to get the moles? Well, that's where they give you the 1.25 liter of the whole 3.2 molarity solution. Because the formula with molarity and a volume is molarity equals moles over liters. And there's the moles that I'm going to use to plug in for my N value. Because N is the moles. MOLES, MOLS, it doesn't really matter. So if I cross multiply this, molarity times liters will get me the moles. So let's just write that out. Moles equals molarity times the liters. So I'll do that. Moles equals, we got the molarity value they told us was 3.20, and I'm going to times that by the 1.25 liters. So there we go. Moles. That was a combination of molarity and moles. Moles. 3.2 times 1.25. I get 4 moles. And this is specifically of the HCl. And that's what's going to go into here. We now have 4 moles. So I'm just checking over my math just to make sure I did everything right. 3.2, 1.25, everything looks good. So now we're just going to plug it into PV equals nRT. 0.980 times the volume, which is X, equals the moles, which is 4, times the 0.08206 times that temperature, which is 303.15. I want to solve for that volume, so all I have to do is just divide by the pressure on both sides, which is the 0.980. Cross that off. And now we're left with X equals, let's see, I'm going to plug this all in. I got the 4 times by 0.08206 times by the 303.15, and then I'm going to divide by that pressure. I'm going to use the whole number up here just to get a more exact value, and press enter. And there you go. Seems like I got 3 sig figs, so maybe I'll say 102. And the unit would be liters. And that's what they asked for. How many liters of the gas? 102 liters would you need? And that's the answer. And always trust your math, guys, right? 102 may seem like a big number. But, I mean, we plugged it in correctly. Everything looks good. We double-checked our math. So it should work out fine. So just always go with your gut, okay? All right. I hope this helped. Thank you so much for viewing the video. Subscribe to the channel if you want to help us out. And I love helping you guys out in these topics in chemistry. We also got physics and math videos if you guys need help there. We're like a one-stop shop, right, for education. Thank you so much for being part of this journey, and I really hope you're learning from us. Good luck on those tests and quizzes. I'll talk to you soon. Okay, bye-bye.